Hi everyone. Today we'll be starting a new chapter called Permutation and Combinations. So, permutation and combinations is probably one of the most tiring, annoying, irritating chapters for most of us. Well, it was for me and a lot of my friends as well. And major reason is that there are no, particular formulas, right? Besides a few no particular formulas. What I mean by this is this is mostly made up of logic, logic and intuition, logic and intuition. So a lot of times, what happens is that we end up, coming up across different questions with different situations, and obviously we're confused. We don't know how to do it. We're trying to use certain formulas, 3p2 times 3p1 and all those sorts of formulas, and we're not able to work it out. So essentially what I want to get across with this playlist of permutation combinations is I want to share different sort of questions you can come across and ways you can tackle them, so that if you pick up concept A or concept B or concept C, you can kind of extrapolate those into questions that you're seeing for the first time, right? You want to wire your brain, or oil your brain as efficiently and as much as possible, so that when you do experience new questions, you can extrapolate the same logic, same concept to those ideas. All right. So let's start with a very simple idea of counting, right? You must have heard about counting principles, right? So permutation and combinations in and of itself is about counting, which means how many, right? Which means how many. Okay, so let's take a look at this question. And you know what? Pause the video and just give it a try, right? Just give it a try with whatever method you have in mind. If you have learned something before, give it a shot. If you don't, do it use some brute force and just list out the numbers. But do give it a shot. All right, so this is the first question, which is asking us how many three-digit numbers can be formed using the digits 1, 2, and 3. Okay, so let's just do it the most easiest way. Let's just list out everything. So we have 1, 2, 3, 1, 3, 2, 2, 3, 2, 3, 1, 2, 1, 3, 3, 1, 2, and 3, 2, and 1, right? In a total of 1, 2, 3, 4, 5, 6. 6 ways, right? 6 ways. Okay, let's take a look at another question. Again, simple question, not too complicated. Pause and just give it a try. All right. So we're asked, how many 4-digit numbers can be formed using the digits 1, 2, 3, and 4 without repetition. Without repetition. That's the game. Okay. All right. So let's take it. Let's start with 4. Okay. Let's make the first digit 4. So we can have 4, 1, 2, 3. Then we have 4, 1, 3, 2. Just swapping the last two numbers. Then we can change the 1, we can make it 2, and you can say 3 and 1. And then 4, 2, 1, and 3. And then we have 4, 3, 1, 2, and 4, 3, 2, 1. Now if you notice, these numbers are just 6 ways, right? So this is 6 ways for when 4 came first. So we can have another 6 ways for when 3 comes first, another 6 ways for when 2 comes first, or we start the 4 digits with 2, and another one for 1. So in total, we can actually get 24 ways, right? I hope you get the idea, right? This is how permutation combinations begins. It's by counting. It's by counting how many ways a certain thing is possible. All right. So again, the IB will never ask you to do something like this where you have to list out things. But I'm just trying to get the concept home at the moment. Okay, so that brings with those two examples, I just want to bring us to the next part, which is addition versus multiplication. Okay, and this is something you can kind of treat like as a rule of thumb, a rule of thumb. What I mean by addition versus multiplication is there will be certain times where you have to add certain groups or permutations together, and there will be certain times when you have to multiply them. So how do you really decide that? So whenever you have to add, there's going to be an or. Whenever you have to multiply, there's going to be an and. So you can say, I want to wear jeans or shorts. So in that situation, you add. When you want to wear, when you have something like jeans and sneakers, that's when you multiply. Okay. Keep that in mind as we move forward. All right. So now let's take a look at an example. We're given that a person can travel from city A to city B via a road, train, or flight. Okay? So the goal is, the key is to know that this is or right here. Okay? So the question is, how many ways can a person go from city A to city B? So by road, we have car, bus, and bike. It's a total of 3 ways. In a train, we have express or mail. Okay, these are 2 types of trains. So this is 2. And for flight, we have economy or business. So another 2. Now let's just draw it out for the sake of simplicity, right? So let's say I have city A and I have city B. So this is 1 way, right? Let me change the color. I'll take orange. This is way number 2. Let's say this is by road. And I have way number 3, which is by flight. So car, train, and flight. So now to find the number of ways, I just have to add, right? So I can do 3 plus 2 plus 2. Gives me a grand total of 7 ways. Super simple, right? We just had to add them up. Nothing more to do. Okay? Let's look at another example. This example has a stadium has 5 gates as shown. So we have 1, 2, 3, 4, and 5. Okay? And we have to find the number of ways of going in and going out as per the following conditions. Okay? So in the first condition, let me write it here. We're told that entry and exit from any door. Okay? So we can enter from any door, which are essentially 5 ways, right? And exit. So we have and, so we're going to multiply. So 5 times 5. Remember, we can enter from A, leave from A, enter from B, leave from A, enter from A, leave from C. So 5 entries, 5 exits. So essentially we have 25 ways, no restrictions whatsoever. Okay? Way number 2, or condition number 2, we're given entry and exit from different doors. Well, let's say if I enter from any one of the 5 doors, right? So if I enter from any one of this, I have 5 options, right? So let's say if I enter from here, now I have 4 options to exit from. So I have 5 times 4, 20 ways, right? That's the number of ways I can enter and exit based on condition number 2. Let's look at condition number 3, okay? Condition number 3 says entry from side 1 and exit from side 2. Okay, no problem. How many doors are on side 1? Well, there are 2 doors. So entry from 2 doors, and exit, right? And so again we multiply and exit. So there are 3 doors. So 2 times 3, which gives us 6 ways. Okay. Let me kind of squeeze condition number 4 here. So I'm given entry and exit should be from different sides. Okay. So here we actually have 2 situations. Okay. So I can have entry from side 1 and exit from side 2. Or I can have entry from side 2 and exit from side 1. I hope this makes sense, right? Just rewind it again and think about it. There are 2 options. It's not saying entry from side 1 and exit from side 2. Then I would have just have one of the conditions, but I have to consider both of them in this situation. So because of that, here, if I enter entry from side 2 and exit from entry from side 1 and exit from side 2, it's the first situation. It's essentially, let me change the color here so it makes sense. It's essentially 2 times 3, which is 6. Similarly, this will be 3 times 2, which is 6, giving me a grand total of 12 ways. Okay? I hope this makes sense. It's a super simple question, right? Again, and entry and exit should be from different sides. So I've multiplied these 2 because they're from different sides, but I have to consider both situations in case the situation is, especially the one that is reversed. That's why I have a grand total of 12 ways. All right, let's look at another question. We're given that cities A, B, C, and D are connected by a network of roads as shown below. So we have city A, let me choose the color. Let's make it purple. City A, city B, city C, and city D. Okay. They're connected by a network of roads as shown below. In how many ways can a person go from city A to city D without visiting a city more than once? Okay, without visiting a city more than once. So there are multiple options here. One option is A to D, okay, directly. Then we have another option would be A to B to D. Another option would be A plus B plus C plus D. Okay? I'm so sorry. Let me just fix this up. These are supposed to be arrows. So A to B to C to D. Okay? How many ways can a person go from city A to city B without visiting a city more than once? We're not repeating, okay? So let's say if you go to A to B to C, you don't go back to B and then go back to C and then go to D. No, just visiting once, okay? Without visiting a city more than once. The key in permutations is just comprehending what the question is asking us. Without visiting a city more than once, you cannot visit the city more than one time. Okay, so if you go to B, you must go to D. Okay, I hope that makes sense. So directly to go from A to D, there are 2 ways. So I can just write simple 2. To go from A to B to D, there are 2 ways to go to B and then 3 ways to go to D. So 2 times 3. And similarly, A to B to C to D. So 2 times 2 times 4. Okay, 2 times 2 times 4. That's a total of 2 plus 6 plus 4 times 4 is 16. Okay, so 2 plus 6 is 8. 8 plus 16 is 24 ways. Alright, so now let's go to another concept of filling vacant spaces. I'm sure you must have come across this somewhere before. If not, it's essentially the idea of, let's say there are, 4 friends standing together in a line, waiting to get an autograph by a famous celebrity. And how many ways can they be arranged? Or let's say there are 4 seats on a table. Let's seat A, seat B, seat C, seat D. How many ways can they be arranged? Kind of like that. Okay? So let's start with a question. Best way to, hit across the concept is to do a lot of questions. So first question is, how many four-digit numbers can be formed using the digits 1, 2, 3, 4, and 5? Okay, so it's quite a common question, very basic question to build permutation combination concepts, especially counting principle concepts. I apologize. So there's a very conventional way to solve these questions. Okay, so let's say we're not allowed to repeat the numbers. Okay, so we can only use 1 ones, 2 ones, 3 ones, 4 ones, and 5 ones. How would we solve this? Okay, so I'm gonna draw out four digits. Okay, like this. All right. So I have 4 digits right here, and I can pick any one of them to go anywhere. Right? I'm not worried about anything. There are no restrictions, except that I can't repeat this. So I have 5 options to put here. Right? I have 5 options. Now, once I've taken up, let's say I've used this digit. Now I have 4 possible options for this hundreds place, and then I have 3 options for the tens place and 2 options for the ones place. Now I just have to multiply these options, and I have a grand total of 120 ways, or 120 numbers can be formed using the digits 1, 2, 3, 4, 5 without repetition. Now, what would be the case if repetition was allowed? Well, then I have 4 slots, and I can use any 5 of the numbers as many times as I want. Right? I can use 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 2, 1, 1, 5, 5, 1, 1, and again multiplying them all together, giving me total of 625 numbers I can form with 5 digits, from 1, 2, 3, 4, 5, and I can make 4-digit numbers, 625 4-digit numbers. Okay, now let's look at another question, but it's just slightly changed. Okay, the approach is the same. I highly advise that you pause the video and just give this question a try. Okay, so assuming you have given a go at it, let's say we have again 4 spaces for 4 digits, and how many numbers can I put in the thousands place? Well, I can actually only put 4 numbers. And the reason is I cannot put a 0 here, because think about it. If I put 0, 1, 2, 3, this is not a 4-digit number anymore. It's a 3-digit number, right? It's 123. It's not 123. That's not a number. It's just 123. So besides 0, I can put any of these numbers. Okay? Perfect. Now let's say I selected 1 to go here. Now I'm left with 4 options. So another 4 options can go here, right? Because I can put 0 here. That's not a problem. The only problem is putting 0 in the thousands place. So let's say I put number 2 in this situation. Now I'm left with 3 options. So I put maybe 0. And then I have 2 options. So in total, I have 96 ways of forming a 4-digit number using 0 to 4. Similarly, how would I do if repetition was allowed? Well, again, I can only have 4 options here because I can put any number but 0. But after that, I'm open to anything. So 5, 5, and 5. I can put 1, 0, 0, 0, or 5, 4, 0, 0, 0. Doesn't matter, right? So I have 20 times 25, which is 500 ways. Okay, super simple. I hope these kind of questions help clear up any sort of confusion you may be having previously. Okay, now next question is, how many 4-digit odd numbers can be formed using the digits 1, 2, 3, 4, 5? And key is without repetition. Okay, cannot repeat them. Now, what is the requirement to create an odd number? Well, to the condition to create an odd number is that I cannot have an even number at the end. So I cannot have a 2 and I cannot have a 4. Okay? Besides that, I can have anything. So let's say 1, 2, 3, and 4. Right? So what I'm going to do is I'm going to start filling in the restrictions first. Right? I cannot have an even number in my ones place. Right? This has to be an odd number. Right? So how many odd numbers do I have? I have 1, 3, and 5. So I have a total of 3 ways. Okay? Then let me just put the multiplication sign here. Now I can go ahead and do whatever I want. Right? Now let's say I've taken 1 to be in the first position. Similarly, let's say I put 2 here. So now I have a total of 4 ways. No restrictions whatsoever. So 4 ways is in this position, and then I have 3, and then I have 2, right? So that gives me a total of 12 times 6, which is 72 ways, right? So notice, again, I'll just repeat what I did. I first filled in the restriction, right? I took care of the restrictions so that I don't face any sort of complications later on. That's my goal, right? Once a restriction is properly filled up, then I'm okay to work around with all the other areas without any problem. Okay? Alright, so let's go to the next question. How many 4-digit numbers divisible by 4 can be formed using the digits 0, 1, 2, 3, 4? Okay? The only difficult part is figuring out how to create a number divisible by 4. Okay? To create a number divisible by 4, the last 2 digits must be divisible by 4, which means, let me change the color now. Let's take red. Okay? Which means 1, 2, 3, 4. Okay? 1, 2, 3, 4. Perhaps I could go with, a little bit more. So 1, 2, 3, 4. Do you have another space on the next slide? No, I don't. Okay, so I'm going to have to cram it up in here. So 1, 2, 3, 4. How many do I have? 1, 2, 3, 4. Maybe I can put one here. 1, 2, 3, 4. And 1, 2, 3, 4. Okay? So now the last 2 numbers should be divisible by 4. Well, I know 0, 4 is divisible by 4. I know 1 and 2 is divisible by 4. I know 2 and 4 is divisible with each other. I know 2 and 0 are divisible. 32 is divisible. 40 is also divisible, right? 40 is also divisible by 4. So, yeah, I think that's about it. 0, 4, 1, 2, 2, 4. It's basically using your multiplication tables and just figuring it out loads and loads of cases. Now, let's look at the first case, okay? Let me change the color again. I'll take light blue. Okay, so we've already allocated 2 numbers out of the 4 numbers we're given, right? We've already allocated 2 numbers. So let's say 0 and 4. Okay, you know what? No, I can't use this color. I'll use purple. Okay, so 0 and 4 is already used up. How many options do I have? I have 3 numbers, okay? And then I have 2 numbers. And this is already fixed, okay? So this is just 1 number is possible here and 1 number. So this is 1 and 1. So this gives me a total of 6 ways, okay? Now let me just erase this part again. Okay, next is, again, now 1 and 2 is taken up here. So, right, 1 and 2 is booked. It's already taken care of. What other options do I have for this portion? Remember, I cannot put 0 here. So don't put 3. It's actually just 2 options. Now let's say one of this, let's say 3 is at the thousands place. Now I have another 2 options. Right now I can put in 0. So another 6 options. No, sorry, my bad. 4 options because this is 1 and 1. Okay? 4 options. Okay? Let's take a pen. Let's make 4. Okay, 4 options. Now I hope it starts making sense, right? Again, 2 and 4 is taken away. So when 2 and 4 is taken away, what other options do I have? I can't put 0 here. So again, I have 2 options and another 2 options. So 2 times 2 times 1 times 1. which is 4. Remember, 1 and 1 times 1 is because 2 is already allocated. Only one number can possibly go here. Another one number can go here. That's why it's 1 times 1. Okay? For 20 ending, I can again put 3 and 2, which gives me 6 ways. Here again, it's 2, 2, and here it's 3 and 2, right? I'm just using the same logic to finish up the remaining 2 parts. So for numbers ending in 32, I have another 4 ways. Number ending in 40, I have 6 ways. So 10, 10, 10. Total is 30 cases. Okay, total is 30 cases. Okay, next question. I'm given that this is a little bit of a trickier question. Maybe it can come in the IB, but yeah, this is something that's more likely to come in the IB exams. Regardless, let's solve the question. So we're given that if the number of 5-digit numbers with distinct digits and 2 at the 10th place is 336k, then k is equal to what? Okay, if the number of 5-digit numbers with distinct digits and 2 at the 10th place is 336k, then k is equal to what? Okay, so we know it's a 5-digit number, right? It's a 5-digit number. So let's write out 5 digits. 1, 2, 3, 4, 5. Okay, and we know the 10th place, or it's called the tens place, right? Tens place. So we know we have a 2 here. Okay, we know we have a 2 here, right? This is locked up. So 2 is out of the question. Okay, 2 is out of the question. We cannot take it. Okay. What other options do we have now? Well, again, I'm going to be multiplying them. So this is 1 right here. All right, let me change the color again. Okay, so this is out. And let's take green. Okay, this is 1. Okay. Now, how many other options do I have? Well, already 1 is taken, and it's distinct digits. So there's no repetition. No repetition, right? And I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and oh yeah, that's it, 9, right? So total 10 digits. Out of that, 2 is already taken out, right? 2 is already taken out, no repetition, and I cannot put a 0 here. So how many options do I have? I have 8 options. So let's say I took out 1, for example. Now I have another 8 options left. Now, let's say I took out a 0. Now I have 7 options and then 6 options. So I have 336k times 8 times 8 times 7 times 6. That's what I have. Now, if you have the calculator, I doubt such questions will ever come into calculator section because they're just too easy to solve. You can just put in the calculator, divide. But really, I wouldn't multiply these numbers at all. I would just keep it as this, and I would take 8 times 8 times 7 times 6, divide by 336, like this. And if I start crossing off things, dividing by 8 and all those sorts of things, well, here you can see 336 is very much divisible by 6 because 5, 30, 36, this is 56, right? 56. And with 56, we get k is equal to 8 because 56 cancels out with 8 times 7. All right, okay, so let's move to the next question. Again, I will highly recommend you pause the video and give it a shot on your own. So we're asked how many ways a student can answer a multiple correct question with 4 options. So multiple correct is not the same thing as multiple choice. It means there's 1 or more correct options. Okay? Let that sink in. 1 or more. Okay? So now think of this, like let's say you're giving your paper 2 exams for your science exams, and you're filling out an OMR sheet. So you have your question 1 with option A, B, C, and D, right? And you have to fill the bubble in, right? But in this situation, usually in the IB exams of paper 2, you only have one correct answer. But here you have multiple correct. You can have 2 correct, 3 correct, 4 correct, or even 1 correct, right? So let's break it down, right? So there are 2 options for this, right? Let's say I'm doing some comparison question or some number theory question where there are multiple options, multiple right answers. Okay, just a hypothetical scenario at the moment, right? So I can accept this answer or I can reject this answer, right? Similarly, I can accept this answer or reject this answer. I can accept this answer or I can reject this answer. I can accept option D or I can reject option D. So essentially I have two, and 2 possibilities for every single option, giving me a total of 16 ways of answering this question. However, there's a catch. This 16 ways, one of the ways included, one of the ways that is considered is that I reject every single one of these options. That's one of the 16 options, or one of the 16 ways that I say that none of the answers are correct. Now, realistically, that's never the case in any sort of multiple choice questions or multiple correct options, right? Either at least there must be at least one correct option. I cannot just skip or omit answering a question, like for example your SATs, right? You can't just omit answering a question and then expect to get points there, right? You will lose points, right? So either you have 1, 2, or whatever, but you must be selecting at least one answer. So essentially, I have to remove one out of this. That one is the that one way is where I don't answer any of them, or I reject all the options. So actually, in reality, what I actually have are 15 possible ways possible actually, or 15 possible options, not 16. Okay, so there are actually a total of 15. I hope that makes sense. Just break it down. We have we have the ability to accept the answer or reject it, accept, reject, accept, reject, accept, and reject. However, I cannot just reject all the 4 options and expect to get the question correct, right? Usually, such questions always have the option none of the above, but let's assume that none of the options have none of the above, right? So that's the situation. All right. Okay, so building on this question, I think this is our last question for today. A similar question again. Pause, give it a shot, and then I'll explain. Okay. So we're given in how many ways a student can answer 10 questions if questions are single correct type. Now this is the easy part, the single correct type. So there are 10 questions, right? So let's say I have question 1, option A, B, C, and D. So bubble, 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 bubble. Question 2, question 3, bubble, 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 and bubble, all the way down to question number 10, A, B, C, and D, right? So I can fill in. I think option A is correct. I think option B is correct. I think option A, and maybe option D is correct, right? So that's what I've done, right? Now I have to decide if there's a single correct, right? Single correct. So for the first question, if I just had to guess, I would have 4 options, right? Similarly, for question number 2, if I had to guess, I would have another 4 options to choose from. And for question 3, another 4 options. And similarly, I would keep going till I get for my 10th question. right? So I do this 10 times, right? I do this 10 times. So essentially, what my final answer would be is that I would have 4 times 10, 4 raised to the power 10 possibilities. 10 possibilities of answering this multiple choice question, right? I have that's a huge amount of possibilities. I mean, you already know 4 times 4 is 16, 16 times 4 is 64. Add another 4, you're 256. Add another 4, you're already at 1028. So 4 raised to 5 is anyways 1028, and then with another 1020, that's like 100,000 possibilities right there. Got it? Now, second part. If the questions are multiple correct, similar to the previous option, right? So, if they are, what do you say, multiple correct, then what do I do? Give it a shot. Think about it. Okay, so if you use the same logic from the previous question, right? For one question with 4 options, there are 15 possible ways, right? There were 15 possible ways, okay? So that means for question 1, there are 15 possible ways. For question 2, there are 15 possible ways. For question 3, there are 15 possible ways, all the way down to the 10th question. So again, we have 10 times, right? So what this does is actually I have 15 raised to the power 10 possibilities. And I don't even think my calculator at this point can figure out the actual number when I do this, right? I think I'll have to use some software or some website to do this. So I hope this makes sense, right? 15 raised to the power 10. It's the same thing as the previous question. Previous question was just for the first question. Here I have 10 questions, so that's why I'm multiplying 15 10 times, hence giving me an exponent of 15 raised to the power 10. Do we have another one? Nope, that's about it. Okay, so this kind of sums up what I was trying to explain about counting principles and how we can arrange these sorts of things. It's okay if you didn't understand some of these questions in the first go. I would recommend that you revisit the videos or you look at your textbooks and look at the solutions and just try to get in the habit. Sometimes some questions may have a really weird intuitive thinking to it, approach to it, and it just doesn't make sense. And one fine day it'll just hit you like you'll be like, oh my god, okay, this makes a lot more sense, and I'm able to work with it. But you just got to stay consistent. You just have to keep doing questions over and over and over just to get yourself in the habit of solving such odd, you could say, odd type of or questions that you're usually not used to seeing. But once you do get the hang of it, the solution, the idea, the approach, they all start making sense and they all start coming together really well. So I'll end the video on this note. And in the next video, we'll take a look at just permutations and what makes permutations and the importance of permutations especially. All right, so that's about it for this first video of permutation combinations chapter, and I'll see you in the next one.